Hello, students. We are here right now to complete our lab activity. If you recall, we've been talking about acids and bases, and now it's time to complete our lab activity found on page 152 of your books. So if you haven't done so already, be sure to turn there. And the problem of today's lab states, how can acids and bases be identified in the lab? How can acids and bases be identified in the lab? Hopefully you were paying attention before with our notes, and you can certainly scan over your notes, but I'd like you to pause the video now and write your hypothesis before moving on. Alrighty then, you have written your hypothesis, and hopefully you've come up with a good idea, an educated guess on how in the world we're going to be doing this. And so let us now turn our attention to the lab activity itself. In your books, in the observation section, you will see a diagram that looks like this. We are going to be using a device called a microplate. And the microplate, and I'll show it to you in a moment when we get to our virtual lab, is simply a porcelain dish or porcelain plate with little reservoirs in them. These little reservoirs are indented in, and we're going to be using just a small volume of 3 solutions: solution A, solution B, and solution C. And we're going to be performing 3 different tests in the lab in order to identify whether each solution is an acid, a base, or neutral. And to do that, let me just scroll over to our data table. You'll see your data table in your books look very similar to this. And here are the 3 tests we're going to perform. The litmus paper test using both red and blue. The pH paper test, which will give us a color that will match up with a number. The phenolphthalein test, and then we will be able to identify whether it is an acid, a base, or neutral. So you're going to be filling in the data table as we make our observations together. And so now let's go over to our virtual lab here on the video. So here's the porcelain plate that I was describing to you a moment ago. You'll see the porcelain plate, and it's easier if I tilt it here for you. You'll see I have it labeled A, B, and C for the 3 different solutions, and 1, 2, 3 for the 3 different tests we are going to be performing. And so let's begin right now. I'm going to leave the plate here like this, and you'll notice I have our 3 solutions. So I'm going to take our first solution, solution A, and I'm going to put a couple drops under solution A for test 1, test 2, and test 3. Close up the cap, and now I'm going to get solution B. And in the second column under B, I'm going to put a couple drops for the first test, the second test, and finally the third test. Put the cap back on and get solution C. And solution C will go under the column for C. 2 drops for test 1, 2 drops for test 2, 2 drops for test 3. Return the cap and return solution C. Now, I know what these 3 solutions are, and I've already been using my sense of smell to detect an odor for each. Not easy for you to do at home, but I will tell you. Yep, there is a distinctive odor. When you do this in the lab yourself, you'll be able to waft the odors. But I don't want to share those odors with you right now because I want us to perform the 3 tests, beginning with the litmus paper test. Now, as you know, we have 2 different kinds of litmus paper, red and blue. And so we're going to begin with the red litmus paper. We don't need to waste too much litmus paper here. So I'm going to take 1 strip of red litmus paper out. Okay. And I am going to tear it into 3 pieces, 1 for each of our 3 solutions. Solution A, solution B, and solution C. Okay, so here we go. It may be difficult for you to see on the screen, so I will hold it up for you to see as well. And by the way, the red litmus paper is not as red as the container. The red litmus paper is more pink than red. So the first test is the litmus paper test. I'm going to dip the red litmus paper into solution A, and it looks like the red stays red. So in your data table for solution A, the red litmus paper stays red. Let's go to solution B. Solution B, the red litmus paper stays red. Interesting. And now let's go to solution C. Whoa, there we see a definite color change. The red litmus paper is turning blue in solution C. Here we go. I think you can even see that on the screen here. Yeah. All right, now let's go to the blue litmus paper. And once again, the color of the actual litmus paper isn't terribly blue, but we call it blue litmus paper. And here is the blue litmus paper so you can see it. And again, I'm going to tear it into thirds so that we don't have to waste too much here. And so let's begin with solution A. Blue litmus paper stays blue. Solution A, the blue stays blue. Solution B, the blue litmus paper turns red. Can you see that? The blue litmus paper turns red. And finally, solution C, the blue litmus paper stays blue. So let me summarize the results for you for the litmus paper test. The litmus paper test. The end color. The red for test number 1, solution A, the red stays red, the blue stays blue. Solution B, the end color for both is red. For solution C, the end color for both is blue. Now, just with the litmus paper test alone, you probably have a good idea of what each of these solutions are. But let's confirm it with pH paper. pH paper is kind of a neutral color when you first take it out, but I'm going to show you the cylinder here. The cylinder has a variety of colors that we're going to match up the colors to the litmus paper, and each of those colors correspond to a number, and that number is the pH of that solution. So I'm going to hold the container with one hand, and we're going to go to solution A. Solution A, I'm dipping it in, kind of stays a neutral color, and it looks like that color matches up with the number 7. So the pH of solution A is 7. Let's go to solution B. Solution B, woo, that turns a little brighter color. The solution B, I think, matches up with the color corresponding to the number 4. So solution B has a pH of 4. And now let's go to solution C. Solution C, woo, totally different color there. Solution C, that looks like it matches up with number 11. So pH of 11 for solution C. Does that give you an even better idea of what each solution's identity might be? Let's do one final test, shall we? So that's the pH paper test. The last test is my favorite, just because of the word, is phenolphthalein. So phenolphthalein. Remember what phenolphthalein does in the presence of either an acid or a base. Refer to your notes if need be. And so I'm going to put 1 drop of phenolphthalein into solution A. It stays clear. Solution B, it stays clear. And finally, solution C, it is turning pink. It is pink in solution C. I'm going to try and hold this up a little bit so that you can see the color. Can you see it? Let me hold this a little bit closer to the camera here. And maybe you can see, there we go. Can you see that pink color in that third? Oops, I'm dripping it all over. Okay. Believe me, it was pink. Okay. It was pink for solution C. So here we have a very colorful experiment illustrating different colors using 3 different tests: the red and blue litmus paper test, the pH paper test, and the phenolphthalein test. You have your observations now. You have them recorded. Use those observations to identify which solution is the acid, which is the base, and which is neutral. And then write your conclusion, and you're all finished. Let me head back over here to our notes. So hopefully you have been able to identify each solution as either an acid, a base, or neutral. Write your conclusion, then we'll have an opportunity to discuss your findings and see how you made out. Good luck, and for now, bye-bye.